Let's graph the following system of linear inequalities. We are given x is greater than or equal to 0, y minus 3 over 7 times x is greater than minus 3, x is less than or equal to 4, and y is less than 3 over 7x plus 3 halves. Okay, so this is our system of linear inequalities. It actually contains quite a few fractions in here, but there's nothing we can't handle about this. There's nothing to write home about. So let's go ahead and we need to convert this one into slope-intercept form, just like all the other three of them are. So let's go ahead and add 3 over 7x to both sides. So we get y is greater than 3 over 7x minus 3. All right, so we have all four inequalities in slope-intercept form. So let's go ahead and see what this graph looks like. There's our y-axis and our x-axis. This is our positive y direction. This is our positive x direction. We should be very comfortable graphing these linear inequalities by now. All a system is just a set of multiple linear inequalities. Here we're dealing with more than two, so we should get what's called a bounded region for our solution interval. All right, so let's go ahead and graph these. So we have the first one. We'll just start with this purple one. We plug in 0 for x. We get y equals minus 3, so it's going to cross the y-axis right here. And it has a positive slope of 3 over 7. So we're going to go up 3 and over 7. 1, 2, 3, 4, 5, 6, 7. It's going to cross the x-axis right here. And it's just greater than, so we're going to have a dashed or dotted line, which is going to exclude all the points on this line from our solution interval. Okay, so let's look at the next one. Let's look at this one. This one, for x is equal to 0, y is equal to a positive 3 halves, which is right here. It's going to cross the y-axis at 3 over 2, and it also has a positive 3 over 7 for our slope. So we have 1, 2, 3, and we're going to go over 7. This 2 is also going to have a dotted line, because we just have a less than sign. So we're going to exclude all the points on this line. And if you recall from a previous section, two lines that have the same slope are going to be parallel, so these lines are actually never going to touch. All right, it's going to be very useful. I'll tell you why in a second. So we have x is greater than 0. That means we're going to have a vertical line at x is equal to 0. So we're going to have a line right through here. This is going to be our line, x is greater than or equal to 0. And it's going to be including all the points on the y-axis, or just this line, which overlaps on the y-axis. It's superimposed over on the y-axis, just like, well, we saw one earlier. So it's going to include all the points on this line. And we simply have this one left, x is less than or equal to 4. 4 is right here, so it's going to be a vertical line passing through this point. So we're going to have a vertical line passing through the point x equals 4. X equals 4. It's going to continue in both directions. It's going to contain all the values on this line and our solution interval. So let's go ahead and see where our interval is, our solution region. We want all the values greater to the right of this green line. It's greater than x, so to the right of this green line. But we want all the values to the left of the orange line because we want all the values less than x. So right in between this green and yellow and orange line is where we've narrowed it down to. We want all the values greater than the purple line and all the values less than the blue line. So we're talking about all the values in this region right here. This is our solution region. It includes all the possible values that satisfy this system of linear inequalities. This is actually very useful, especially when we're talking about financial applications, manufacturing applications, investment applications. This is very, very useful, has tons of applications. So this is our solution interval, our solution region, and we just need to know how to do this and actually how we got about shading this solution, this region right here. We're just looking at our inequality signs and narrowing it down from there. All right, so let's go ahead and do another one. We have the system of linear inequalities, x plus y over 2. Y over 2 is less than 4. We have y is less than or equal to 8. We also have y is greater than or equal to 0. And we have x is greater than or equal to 0. So this is our system of linear inequalities. All but one of them is in slope-intercept form. So let's go ahead and convert this one to slope-intercept form so we can subtract x from both sides. So we'll have y over 2 is less than minus x plus 4. And go ahead and solve for y by multiplying both sides by 2, which will cancel that denominator. So we have y is less than minus 2x plus 8. All right, so we have this in slope-intercept form. We have this one in slope-intercept form. We have this one, and we have this one. These are our 4 linear inequalities making up our system. So let's go ahead and graph this thing and find the solution region. This is our positive direction for our y-axis. This is our positive direction for our x-axis. All right, this one's actually it's going to be fairly simple. Let's start out with y is greater than or equal to 0. That means we're going to have a horizontal line that is superimposed on the x-axis. These are all the points, all the values where y is greater than or equal to 0, or where y is greater than or equal to 0. So when y equals 0, we're going to have all these points on the line on the x-axis. So we can think of this as y is equal to 0, which gives us a horizontal line on the x-axis. We're going to include all those points on the line. Now we have x is greater than or equal to 0, so we're going to have a vertical line about the y-axis. This is all the points where x is greater than 0. We're going to include all the points on this line, or excuse me, where x is equal to 0. And then we have a region that we're going to shade once we narrow down the rest of the constraints. All right, so let's go ahead and look at the next one. We have y is less than or equal to 8. The point 1, 2, 3, 4, 5, 6, 7, 8. This is where the line crosses the y-axis. It's going to render a horizontal line about y equals 8. It's going to look something like that. It's going to go in both directions, and it's going to include every point on this line. So we have 3 solid lines. All 3 of these lines are possible solutions. I say possible because we're looking for a region that we haven't narrowed down yet. And we're going to do so by looking at the 4th one. When we plug in 0 for x, we're going to have y equals 8. So we're going to have the point right here. We also have 2 other lines that include this point. And we have a slope of minus 2. So we go down 2 and over 1. So we're going to have a dotted line here because we just have a less than sign. We're not going to include any value on this line right here. This is our 4th line. So now we can narrow it down to a region. So we want all the values that are to the right of this orange line, because we have a greater than or equal to sign. We want all the values underneath this blue line, because we have a less than or equal to sign, and we want all the values that are above this green line. So we're looking for this section right here in quadrant 1 between the blue and the green line. Now for the purple, we're looking for less than, so we want all the values less than this purple line. So our solution region is going to be this little triangle right here. This triangle right here. This section is going to include all the possible solutions for our system of linear inequalities that are given. All right, very, very interesting. It's very useful, and we'll actually go into some applications actually in the next section. We're going to look at these inequalities individually are called constraints. These are called constraints, and this is going to be called the feasibility region. And it's going to contain all the possible values that are solutions for the system of linear inequalities. All right, so get familiar with this before we move on. Be sure to look at this video and the previous one a few times so we can get a good handle on actually finding these shaded solutions, these shaded regions. And then we'll move on to actually my favorite section, one of my favorite sections in all of algebra. It's called linear programming. So I'll see you soon.